Hello, and welcome to a tutorial of PolyAnalyst. Today I will show you how to construct a baseline project with multiple types of analysis. The length of this tutorial is approximately 30 to 45 minutes and is conducted using data that is available by request. Feel free to contact us to obtain the sample data and follow along. You may pause at any time to explore functions in PolyAnalyst that are not covered by this tutorial. If you would like additional information regarding the nodes discussed today, please refer to the manual. I will cover data cleaning and manipulation, text analysis, and predictive modeling. Keep in mind that if you follow along, your results may vary from what is shown in this tutorial due to PolyAnalyst versioning differences. The goal of today's tutorial is to garner actionable business insights from unstructured text data. If you have questions about any of the material covered in today's tutorial, please do not hesitate to contact us at support@megaputer.com or 812-330-0110. Let's begin by loading the data. Here I'm starting with a blank project. I drag over the CSV node because I already know that my data is in the CSV format. I right-click on the node and navigate to the Properties option. From there, I browse for my data file. I'll leave the rest of the defaults as is for this tutorial. Before I continue, take a moment here to make sure you are familiar with the different columns in the dataset. This data is from an annual employee survey at Company X. If you are not following along with the provided dataset, the columns in this tutorial dataset are as follows: Employee ID number, 10 columns rating different satisfaction areas from 1 to 5, Employees department, job role, job type, tenure length, sex, and a write-in feedback column, in addition to a column including the employee's manager name and office location. Next, I will place a Modify Columns node in order to verify that all my columns have the correct type indications. The Modify Columns node allows me to exclude columns from the dataset or change the types of the columns that I decide to keep in the dataset. The available column types are seen in the drop-down menus in each data row that corresponds to a column. I can see that the manager and location column has been imported as string, but I would like to have it be classified as text, so I change it in the drop-down menu and execute the node. The third step, and the first one in the data cleaning phase, is to use a Filter Rows node to remove null responses from my main data column. For today's tutorial, I will use the write-in feedback column as the basis for my analysis. I navigate to Properties and use SRL to specify what I want to include in those rows that are not null or empty for the write-in feedback column called Review. Then I execute the node. The fourth step is to run the spell check node. Under Properties, I select the write-in feedback column and leave the rest of the defaults as is. Once the node is executed, enter into the node view by double-clicking on the node itself. Inside, I will sort the spell-checked words by frequency. I can see that the most common misspelling is hindrance. If I click on the gray word at the bottom of my screen, I can see that I have the option to add it as a correction to any of the dictionaries in my project. I will add it now to the spell check dictionary so that in the future, if the spell check node sees this misspelling, it will automatically correct it. Since the spell check node does not automatically make replacements in your dataset, I navigate to the Generate button where I select Replacement node. When I navigate back to the flowchart, I see that the spell check dataset is there. From the spell check dataset, I can move on to the rest of my preparation and analysis. The data cleaning phase I've showed you today is very abbreviated for the purposes of this tutorial. In most real-world analyses, data cleaning accounts for 80 to 90% of manual analysis. Off of the spell check dataset, I will place my first data visualization node. One of my personal favorites is the Parallel Coordinates node. After navigating to the Properties menu, I will choose the Tenure column as my splitting column and the Likert Scale columns as the selected columns. Finally, under the Options tab, I choose Radar from the drop-down menu. When I go back to the flowchart and view and double-click on the node to enter the node view, I can see the results from the Parallel Coordinates analysis. At first, this graph may look hectic. However, if I go over to the right-hand side key and click on each of the options, I can see how they differ from one another. Specifically, notice how when I click through the different tenure links, I can see that less than 1 year and over 20 years have higher satisfaction ratings than the rest of the divisions, but that those employees who selected no response are much less satisfied in the evaluation areas than the others. Now I will place a second parallel coordinates node off the spell check dataset, this time to visualize sex by department. Again, I select the radar graph from the drop-down menu, this time to choose the filled-in option before executing. Entering the node view, I can see the division of sex by department is quite different. For this company, it appears there is a sharp division where forward-facing departments are majority female and back-end departments are majority male. Perhaps the company should look into a more balanced distribution of males and females in its departments, since studies have shown benefits from workplace diversity. One of the main nodes that is necessary in order to prepare for more complex analyses later on is the index node. When I index a column, I'm essentially putting it into a format that can be used internally by later nodes. After placing the node, I select the main write-in feedback column as the column I wish to index. Note that the index node can only run one column at a time. If in your analysis you wish to analyze multiple columns, you should have multiple index nodes. For today's tutorial, I will show you one important component of the index node: how to create your own statistics dictionary. A statistics dictionary is a dictionary that allows you to compare how frequently words in your dataset are mentioned versus English in general. There are also default dictionaries for other languages in PolyAnalyst. When you create your own statistics dictionary, it means that you are not comparing your dataset against general English, but against itself. Your own custom statistics dictionary will tell you what trends are unusual for your specific dataset. Should you decide to use the general statistics dictionary, it will give you more noise in the data, but will still allow you to obtain results. In that regard, using a custom dictionary is more transparent. To do this, I click the Generate tab and select Statistics Dictionary. In the pop-up menu, give your dictionary a name and make sure to create it in the project instead of on the server. Next, I want to make my custom statistics dictionary the default for this project instead of the normal default statistics dictionary. I navigate to File, then select Project Properties and Edit. In the Project Options tab, I expand Default Dictionaries and then select English. Then I select Statistics and uncheck Default and select my own new custom statistics dictionary. Now in each new analysis node I place on the flowchart, my custom statistics dictionary will be used instead of the general default statistics dictionary. Before I move on to the main analysis branches, I will do a little exploratory analysis to help me determine which categories to include in the taxonomy, which will come later. This branch is mainly intended as a how-to walkthrough so you can see how to explore your own data. As such, I will not be spending as much time on this branch as the other nodes. I will attach a keyword extraction node off the index node, and in the Properties menu, I will select the write-in feedback column as the main column for my analysis. In the Options tab, I can select different parameters for the keyword extraction. In addition to noun, I select adjectives under parts of speech. I also select Analyze Negations, Find Dictionary Phrases, and Find Non-Dictionary Phrases. For today, I'll just look at phrases. In your own exploration, you will want to examine both single keywords as well as phrases. When I look inside the node, I can see the keywords that have been extracted. Under the first tab in the Keyword Extraction node view, I navigate to the Generate button and select Link Terms. This will allow me to see statistical relationships between the keyword phrases I've extracted. I name the new node and then execute it in the flowchart. Looking inside the node, I can move the slider to see more or less keywords, then run the Perform layout to see the data in a more intuitive way. The last exploratory step I'll take today is to illustrate how to configure the auto taxonomy. I'll attach the node off the keyword extraction node, then make the write-in feedback column my main column for analysis. In the Case ID Columns tab, I'll make the employee ID the Case ID column, then execute the node. The auto taxonomy node creates hierarchical categories which can reveal useful relationships in my data that I couldn't access via other nodes I've used so far. These categories can help me to narrow down which type of information I want to include in my main taxonomy, which I will later explain in more depth. Next, I will place an entity extraction node to start a new branch of analysis. In a few steps, I will join the results of the entity extraction node with a secondary branch. Under Properties for the entity extraction node, I select the Manager and Location column because I want to separate the Manager and Location into two columns for later analysis. I leave all the other tabs as default except the Entity Links tab. There I add a new link called Manager and Location and assign it two arguments, one for People, which will capture Manager, and one for Geo-Administrative, which will capture Location. Then I execute the node. If I navigate into the Entity Extraction node view and navigate to the Entities tab, I can click through the different entities extracted by the node. Click on any of the entities and a toolbar will appear at the top. Now I will select Generate Dataset and name it, and it will create a dataset where I can expand rows by the entities they contain. Go back out to the flowchart and you will see the node you just created. Navigate to the Properties menu and under the Settings tab, select Expand Rows by Entities under the first drop-down menu. From the second drop-down menu, select the Manager and Location entity we created. In the Selected Columns box, you will see 4 columns appear. We only want to keep the string columns for People and Geo-Administrative. If I go into the node view for the entity dataset, I can see that the 2 columns have been added, one for People and another for Geo-Administrative. However, it would be better if these were named in a more transparent way. In order to clean up these columns, I will need a Modify Columns node. So, I drag and drop a Modify Columns node, connect it to the Entities dataset, and open up the Properties menu. Inside, I rename People as Manager, and Geo-Administrative as Location. Additionally, I select the original combined Manager and Location column to remove it from the dataset. A note here, for my analysis today, I want to leave the Manager and Location columns as string rather than text because there are only a certain limited number of options for these columns. Compare this to the sort of free-form, unstructured data contained in the write-in feedback column. I leave the rest of the tabs set to their defaults and execute the node. Next, I'll start the second branch of my analysis by focusing on sentiment analysis, which is based on the content of the write-in feedback column. I will place a sentiment analysis node off the index node, then open up the Properties menu. Now I will turn the bulk of my analysis to the write-in feedback column, which I will make the selected text column under the Columns tab of the Sentiment Analysis node. After executing the node, I enter the node view and from there can explore the different aspects of the sentiment analysis. If I navigate to the Summary tab, a toolbar appears that includes the Generate button. I'll click it and select Dataset from the menu. I give the new sentiment dataset a name, then navigate back to the main flowchart. Much like the entity extraction dataset I created, this sentiment analysis dataset will allow me to add on additional sentiment information to the rows. If I open up the sentiment analysis dataset, I can see that various types of sentiment information have been added to the data, but the information contained in these columns is kind of confusing. Just to make things as transparent as possible, I'll now add a Modify Columns node where I'll clean up the type of sentiment information included in the data. I first want to rename the type column as Sentiment, which has 3 classifications: positive, negative, or neutral. Then I want to remove all the columns except Degree, which will give me a numerical column of the sentiment ranging from -5, or very negative, to 5, very positive. When I execute the node and enter the node view, I can see that the changes have been made in the sentiment dataset. Next, I will join the two branches of my analysis. So, like I just mentioned, I will now place a join node to join the datasets from the entity extraction and sentiment analysis branches. Because both datasets have the employee ID column, I'll again pair them up under the Key Selection tab. Under the Join tab, I'll again use an inner join. In column selection, I'll add the columns from the left dataset and the degree and sentiment columns from the right dataset. Then I'll execute the node. As a rule, you should navigate into the node view to double check that everything looks right. Before I move on to the last branch of the analysis, I will place an area chart off the join node to visualize sentiment by department. This will help me to get a feel of the distribution of the data. Under the Columns tab and the Properties menu, I make departments the x-axis column and sentiment the splitting column. Then I execute the node and enter the node view. Like I mentioned regarding the sentiment analysis node, it's important to keep in mind that in this data, satisfaction is self-reported, but sentiment is extracted automatically based on language patterns in the unstructured text data from the write-in feedback column. Note how accounting, operations, sales, solutions, and support seem fairly consistent, with about half or a little less of the records being positive. HR is different because even though there are still more negative than positive reviews, the ratio of positive to negative is smaller. The analytics department is the real outlier here. Unlike any of the other departments, analytics has more positive than negative reviews. This company should look into both the HR and analytics departments to figure out what they are doing differently from the other departments. The last branch I will make today will be based on a taxonomy. A taxonomy is basically a hierarchical filtration system which allows you to categorize your data. Since today's tutorial is not focusing on how to create taxonomies, I'm using a taxonomy I've already created. Taxonomies are typically constructed after preliminary data exploration and can take upwards of 4 hours for an analyst to create. After I've attached and executed my pre-crafted taxonomy, I open the node view. Inside, I see the top-level category, which I will call the root. Since my data are from employee surveys, my root is called survey. The children of the root are the top-level categories for my taxonomy. If I click on the root and navigate to the Distribution tab, I can see the amount of records captured by each category. As with all nodes in PolyAnalyst, the taxonomy node supports drill-down capabilities, which I can see when I double-click on the bars in the distribution graph in the taxonomy. Doing so takes me to the child categories of the category I selected. I drill down through 2 levels to get to the grandchildren of the top-level categories. Clicking on these categories shows me the records that are captured by this hierarchy. The Properties tab gives me access to the PDL expression used to extract those records. Again, for more information on the different components of the taxonomy, please refer to the specialized tutorials or the manual. The next step is to place a score taxonomy node and attach it to the spell-checked and indexed dataset. Using the score taxonomy node will enable me to add taxonomy levels to each of the corresponding rows. I open up the Properties menu and make sure that under the Settings tab, the taxonomy scoring mode is Taxonomy Levels as Columns. Also, I will start from level 1, which is my main top-level category, and include all the levels. Under the Independent Columns tab, I select all the columns, and under the Dependent Columns tab, I rename the taxonomy levels to be more transparent. I will make the top-level categories as Topics of Interest, the second level as Subtopics, the third level as Details, and the fourth level as Subdetails. Notice that if you open up the resulting dataset, not every record will have all 4 of the columns. This is not crucial for my analysis today, but is good to keep in mind for future analyses. Before I go any further, I will analyze the distribution of sex by topic of interest in a parallel coordinates node. The motivation for this is the drastic imbalance I noticed earlier in a previous parallel coordinates node, which shows sex by department. Recall that many of the departments in this company are divided, with the front-end ones being primarily female and the back-end ones being mostly male. Due to that distribution, I am curious to see how sex affects the topics employees are interested in. In the Properties menu under the Columns tab, I make sex the splitting column and topics of interest the selected columns. Under the Options tab, I choose Radar from the drop-down menu and select the filled-in version of the graph. Entering the node view, I see that there is a drastic separation of the topics of interest by male and female, which are shown in color on the graph. Males, in blue, are much more interested in resources, forward-facing, and environment, while females, in red, talk more about the remaining topics, including leadership, consequences, human resource, and labor division. It is interesting to note that although the previous parallel coordinates graph reveals it is mostly female employees who comprise the forward-facing departments, most of the discussion regarding client-related topics is generated by males. Before I can make any conclusions, however, I need to explore this topic in more depth. In order to do so, in the next step, I will incorporate the sentiment information from previous branches into the current branch. As I just mentioned, now I will use a join node to join the main analysis with a taxonomy-based analysis. When I connect the joined entities and sentiment dataset, I make it the left dataset, and the taxonomy-based dataset becomes the right. Much as before, in the Properties menu under the Key Selection tab, I pair up the employee IDs. Under the Join type, I select an inner join, and under the Column Selection tab, I select everything from the left dataset and only the 4 taxonomy levels from the right dataset. This join node is the last data transformation I will do. The last phase of today's tutorial will illustrate several different types of analyses. First, I want to follow up on the interesting distribution of male and female discussion on the taxonomy topics I observed in the previous 2 parallel coordinates nodes. To stick with the same style of analysis, I will place another parallel coordinates node off the latest join node. Under the Columns tab in the Properties menu, I'll make sentiment the splitting column and topics of interest the selected column. Under the Options tab, I'll choose Radar from the drop-down menu and select the filled-in version of the graph. After entering the node view, I can see that there is a pretty sharp division of positive and negative discussion in almost all of the taxonomy topics. Interestingly enough, the one topic that has a closer ratio of positive to negative records is the taxonomy category forward-facing, which is the category I'm already most interested in. As a recap, for this company, most of the employees in forward-facing positions are female, but the majority of the discussion regarding forward-facing topics is generated by males. This company might want to obtain additional feedback from its female employees in forward-facing positions to see if the positive to negative sentiment ratio changes. Doing so would give the company a more accurate read on how it's going with employees who experience the day-to-day of forward-facing business. The second analysis I will do is to place a link analysis node off the latest join node. Inside the Properties menu, I will select the location, tenure, and topics of interest columns, since up to now my analyses haven't examined these together, and I want to see if these columns have a relationship. For a more intuitive view, I navigate to the small Perform Layout button with a play arrow in the middle. Location is shown in blue, tenure in red, and topics in green. Now I can clearly see a couple key points. First, there are 5 topics: compensation, resources, labor division, leadership, and projects, but only 2 are directly associated with the location. Compensation is associated with Philadelphia, and resources is associated with New York. Furthermore, there is a direct relationship with compensation as a topic of discussion and a tenure length of 3 to 5 years, as well as one between resource and labor division topics and a tenure length of less than 1 year. Projects are linked to a tenure of 1 to 5 years, while leadership is tied to a tenure of 5 to 10 years. It is important to note that New York has a direct relationship with tenure less than 1 year. Plus, Philadelphia is correlated with a tenure of 15 to 20 years. Other cities are linked to different tenures, which joins most of the chain together, but for my analysis, the taxonomy topics comprise the main focus. In terms of results, the company might want to investigate whether it is Seattle employees or employees with a tenure of 3 to 5 years that are discussing compensation, since I know from the previous parallel coordinates node that most of the records dealing with compensation have negative sentiment. From the same parallel coordinates graph, I know that labor division and resource-based topics are also mostly negative. This company would also want to address the resource and labor division concern in its New York location, specifically for those employees who have been there for less than 1 year. For project and leadership, I know from before that both of these topics are majority positive, and I can see now that both are tied to different tenure lengths. From a business perspective, the company might want to look into these positive sentiment correlations so it can outline a set of best practices. Next, I will connect a tree map node in order to examine the interaction between manager and sentiment. In the Properties menu under the Select Columns tab, I make the Manager column the Hierarchy column, the Sentiment column the Area Size, and Degree Color. By executing and then entering the node view, I can see that certain managers are correlated with records expressing negative sentiment, shown in red. Others are more neutral. Some managers are linked to majority positive records. This company might want to contrast the practices of managers who correlate with negative sentiment against those of managers with positive sentiment to identify best and worst practices and determine if any behavior should be modified. The last type of analysis I will conduct today is predictive analysis. In order to run the predictive analysis, I first need to split my data into training and testing data. The idea behind this division is that I will train the predictive algorithm on the relationships present in the training data, and then apply the algorithm to the unseen data in the test set. The first node of this process is the partition node, which I will attach off the main join node. Inside the first tab, I indicate that I only want 2 partitions, then I execute the node. Once inside the node view, I can see that an additional column has been appended with either 1 or 2, randomized for each record. Now I will use a pair of filter rows nodes to separate the testing and training sets. I will attach both off the partition node, and under the Properties menu, I use an SRL expression to make a partition ID of 1, the training set, and a partition ID of 2, the test set. Now I will carry out the predictive analysis training. Specifically, I want to be able to predict the sentiment of a record given the other information about it. To do this, I'll use a shade node. Under Properties, make Sentiment the target column, and make all the other columns except Employee ID, Partition ID, and Degree the independent columns. The output of this node will tell me several things. Right now, I'll focus on the Predictor Importance tab. Once I navigate there, I can see that departments, satisfaction with planning, taxonomy details, and manager are the independent variables found to condition whether a record's sentiment is positive or negative. Specifically, these are the subtopics for my taxonomy and the satisfaction rating for planning. Note that shade node does not automatically perform predictive analysis. In order to apply the algorithm I've learned in the shade node to new data, I must first connect a score node. I'll attach the score node first to the shade node, then to the filter rows node, which contains the test set, so the algorithm has access to the test data. I do not need to adjust anything in the Properties menu, so I'll go ahead and execute the node. After entering the node view, I can see that on the right-hand side of the dataset, there are several appended columns. The sentiment shade decision column is the algorithm's predictions for each record in the test set. This sort of prediction is especially useful in large-scale projects since I only need to train the algorithm once. After I train the algorithm on a representative training set, I can then pipe large amounts of unseen data through the score node to obtain the predictions for the column I'm interested in. PolyAnalyst can be used in a similar way to quickly pinpoint major discussion topics in any live data stream in near real time, such as on your company's feedback page. This concludes today's tutorial. Using PolyAnalyst, I have illustrated several different data analysis techniques which can be applied to your own projects. Thanks for watching, and please contact Megaputer Intelligence with questions or if you would like additional information about the power of PolyAnalyst.